Good evening, everyone. This is January 2016, Unit 1 of IAL Chemistry. In this session, I will discuss MCQs and the structure questions I will solve on request. If you want me to solve any of the structure question, just comment the question number or the part in the comment box. In question 1, which row in the table shows the number of proton, neutron, electrons in fluoride ion? So because it's an ion, and it's a negative ion, so it means electron should be more than proton. So when we check the periodic table, fluorine is 9 and 19. So number of the protons, there are 9 protons, neutron 19 minus 9, so 10 neutrons. And because it's a charge, so extra electron is there, so it will have 10 electrons. So 10 electrons, 10 neutron, and 9 proton. That's why D is the right answer. A sample of oxygen contain isotopes 16, 17, 18. How many peaks of O2 will be there? So how we can identify how many peaks of O2? If maybe both of them are 16, so 16 plus 16, that is 32. Or maybe one is 16, another one is 18, so that will be 34. Or maybe 16 and 17, so that will be 33. Then when we check the combination with 17, 17, 16 or 16, 17 is already there. 17, 17, but 17, 17, that will make 34. So these peaks will be at same point, so this will be a common peak. Then we have 17 and 18, which is equals to 35. And we have 18 and 18, that is equals to 36. So 1, 2, 3, 4, and 5 peaks will be there for oxygen O2 plus charge. That's why B is the right answer. For question 3, 200 grams of solution contains 0.015 gram of solute. In the solution, the concentration of solute in parts per million. So mass of solute divided by mass of the solvent or solution into 1 million, that will give us concentration in ppm. So mass of the solute 0.015, mass of the solvent 2000 into 1 million. So when we work out, it will come out as 7.5. So B will be the right answer. For question 4, what is the concentration in moles per dm cube of a solution 10 gram of sodium carbonate in 250 cm cube? So concentration in moles per decimeter cube. So we have the mass, we have to convert it to moles. Moles equal mass in gram divided by molar mass. So what is the molar mass? Sodium is 23 multiplied by 2 plus carbon is 12 plus oxygen is 16 multiplied by 3. This will give us the moles, and the volume should be in dm cube. So it's 25 cm cube. We'll divide by 1000, so 0.25 decimeter cube. Then the concentration, the moles divided by volume. So 10.6 divided by the molar mass, we'll get the moles, and divided by the volume, so it will come out as 0.4. Then enthalpy level diagram for a reaction is shown. Which row in the table is correct for X and Y? So X is representing the reactants, Y is representing a product, and a product energy is more than the reactant, so the forward reaction is endothermic. So X is reactant, Y is product, and the forward reaction is endothermic. The table shows the mean bond enthalpy for some covalent bonds. What is the approximate enthalpy change for the reaction? So enthalpy change for the reaction is bond breaking minus bond forming will give us enthalpy change. So reactant side is the bond breaking side, product side is the bond forming side. So what are the bonds we are breaking? C double bonded with C, so 612 plus one CH bonds are there, so CH bond 413, and how many? 1, 2, 3, 4. So it will be 4 multiplied by 413 plus BR bond 193, so that is bond breaking. And bond forming, CC bond is there, so 347. CH 1, 2, 3, 4, that is 4 times 413 plus CBR bond, so CBR 290, and two of them, so 290 times 2. So bond breaking minus bond forming, that is equals to enthalpy change. So when we solve this, B will be the right answer. The first 6 ionization energy in kilojoule per mole of an element are, so 1086, 2353, 4600, 6000, and then 37,000. So this is a big jump. So when big jump, it means that these electrons are removed from the same shell, and whenever electron is removed, it is always removed from the last shell first. So 4 electrons are there in the last shell, and then this 37,000. Why? Because the electron is removed from inner shell. So how many electron in the last shell shows a group number. So this element belongs to group 4. In question 8, different graphs are given. Each diagram shows a trend in ionic radius force. The diagram is not to scale. Which diagram shows a trend in ionic radius? So down the group, the size lithium, sodium, potassium, rubidium. So basically it's down the group, and down the group the the number of the shells increases. So the size will also increase. So which graph is showing the increase in size? A is showing the increase in size. That's why A is the right answer for this. And across the period, which diagram? Because sodium, magnesium, aluminum, silicon, so this means it is across the period. So across the period, what happened? And you can see sodium plus 1. So when sodium is plus 1, it means for sodium, which is plus 1, it is having, sodium is atomic number 11, so 11 protons and 10 electrons. Magnesium plus 2 means 12 protons, 10 electrons. Aluminium plus 3 means 13 protons but 10 electrons. And silicon plus 4 or 4 plus means 14 protons and 10 electrons. So 14 electrons are attracting 10, 14 protons are attracting 10 electrons. So greater attraction across the period, what we'll observe, the size will decrease. So which trend is showing decrease in size? The graph. So D is showing that the size is decreasing. That's why D is the right answer. Question 9. So in question 9, some energy changes involved in a Born-Haber cycle. Electron affinity means when electron is added to a neutral gaseous atom. Lattice energy when ions form a compound. Standard enthalpy change of atomization when 1 mole of gaseous atom is formed from its element. And standard enthalpy change of formation means when element form a compound. So which enthalpy change is represented by P? So solid change to atom. So this is atomization. which enthalpy change is represented in Q? Elements form a compound, so when elements are forming, like potassium is element in their standard state form a compound. We call that as a formation. That's why D will be the right answer, because D is representing enthalpy change of formation. And then enthalpy change or energy change. So a molecule change into atom, gaseous atom. So again, this is atomization. So C is the right answer, because 1 mole of a gaseous atom is formed from element in its standard state. The diagram which is not drawn to scale shows a Born-Haber cycle for potassium chloride. Their energy given in kilojoule. What is the value for W? So overall energy change is independent of the route or the path which we follow. Where the two arrows are pointing out, that is the start of the cycle, and where the two arrows are pointing in, that is the end of the cycle, because the two arrows are pointing in. So if we follow any route, the overall energy change does not depend on the route or the path which we follow. So we have two routes here to reach. This is route 1 and this one is route 2. So route 1, the overall energy change is independent of path. So energy change of route 1 is same as energy change of route 2. So when we write the equation, W plus 419 plus 122 plus addition is there, but because the value is negative, so it is W plus 419 plus 122 plus minus 349 plus minus 711, that is equals to minus 437. So we will solve for W. So it will come out as 82 kilojoule per mole. So C will be the right answer. In which row table shows a lattice energy? Lattice energy depends on the size of the ion, should be small as possible and charge should be greater. So we have calcium fluoride, potassium fluoride and potassium iodide. Iodide ion is greater in size. So here the highest one should be calcium fluoride. Why? Because the greater charge is there and small size ions. So calcium fluoride will be the highest, and potassium fluoride, potassium iodide will be the lowest. Why? Because size of iodide ion is greater, so less attraction, smaller lattice energy, so this should be low, and this will be moderate in between. So which value is the highest? This is the highest, lowest and moderate, so that's why A is the right answer. Question 12. Experimental value of lattice energy of beryllium iodide and theoretical are different. What is the reason for different? Because what this beryllium ion will cause? It will cause a distortion to iodide ion. That's why the theoretical lattice energy and the practical lattice energy are different. So beryllium ion is smaller and it polarized the iodide ion. That's why we have a difference in the lattice energy values, theoretical and experimental values. Experimentally, it will be higher as compared to theoretical value. For question 13, carbon, diamond and oxygen both have covalent bond. What is the best reason for that diamond has a much higher melting point? So higher melting point depends on intermolecular force or type of structure. So diamond has a giant structure where oxygen is a simple molecular, so B is the right answer. The bonding in solid ammonium chloride. So ammonium chloride, when we draw the structure, there's a covalent bond between nitrogen and hydrogen. Then there's a dative bond, and this charge ammonium ion attract the chloride ion. So there's ionic bond as well. So it is having all type of bonds: covalent, dative, and ionic. For question 15, one of the isomers with formula C4H8, the possible name of this isomer. So the heavy groups are on the same side. So if heavy groups are on the same sides, this will be cis or Z. And then what is the name of this compound? If we count the number of carbon, 1, 2, 3, 4. Second position, we have a double bond. And 4 carbons, it is butene. So it is either cis butene or Z butene. An electrophile is a species. So electrophiles, they accept pair of electron from a covalent bond or attracted towards the covalent bond. Electron rich side, like if we have alkene and we have here an electrophile like HBr, this is partial negative positive. So it is attracted towards the electron rich side and try to accept electron from the covalent bond. So A is the right answer. It is not necessary that it should have a complete positive, always positive charge. It is a species which is electron deficient or attracted towards the electron rich side. Question 17. Alkene react with hydrogen. 0.2 moles of alkene reacted with 19.2 dm cube of hydrogen. So 1 mole of a hydrogen, basically if there is a 1 mole of hydrogen, it will react with 1 double bond. So we'll find the mole ratio. Alkene is 0.2, but hydrogen volume is given, so we'll find the mole 19.2 divided by 24. That will be 0.8. So it means that the ratio of alkene to hydrogen is 0.2 is to 0.8, or simplest ratio 1 is to 4. It means there are 4 moles of hydrogen. So it means this alkene contains 4 double bonds. That's why A is the right answer. So this was January 2016, Unit 1 of IAL Chemistry. If you want me to solve any structure question, any part, the structure question, you can just mention the question in a chat or a comment box, and I will upload that video.